Hello, algebra students, and we're going to have another video. Oh, I forgot to introduce myself. What if you don't know who it is? It's Mr. Lawrence. Sorry about that. All right, we're going to have another video on graphing parabolas. This time, they're only going to have one x-intercept, or possibly zero x-intercepts. Remember, a parabola does not have to cross the x-axis. Doesn't have to. The ones we did yesterday, maybe they cross something like that. Absolutely. But they don't have to. We could have a parabola that does this. It does not cross the x-axis, or it might even open downwards, okay? It could also be sitting on the x-axis, where it goes kind of like that. It's only touching at the one point. All right, so, pardon me. It's all going to be about the discriminant. We always start with the discriminant, right? It tells us how many x-intercepts, how many solutions, how many roots, how many zeros there are. So let's go A, B, C. And you got to be careful here. You got to pay attention to details. Some of you just want to write down numbers. This is not a 4. It's a -4. So A, B, C, easy as 1, -4, 4. And then when you go to do the discriminant, the b squared minus 4ac part, you have to use parentheses. Don't argue with me, Joy Conwell. All right, so I've just made a mistake there, pardon me. I'm going to do b squared, but I'm going to put it in parentheses. So I'm going to put a -4 in parentheses, and then minus 4 times a times c. Okay, this is very important because this means -4 times -4. It does not mean 4 times 4 and then it's negative. So this will be a 16. And then here I've got one negative in the multiplication problem. And I'm going to get 16 when I'm done multiplying. So therefore my discriminant is 0, which, as Alison Pasquale would write, there would be one solution. This is how she would do it, and this is a good way to do it. So there's one solution, all right? Now, this one solution has to be on the x-axis. I'm not going to use the quadratic formula. Now, somebody's going to argue with me, I use the quadratic formula. Yeah, that's fine. Go ahead and do it. I'm not going to. You're allowed to. I'm just going to go to the vertex. I'm going to go right to the vertex. And I'm going to use x equals the negative of b over 2a to get the x-coordinate of the vertex. So if b is -4, the negative of -4 is +4. And then 2a. And so this is 4 over 2. Or 2. The x-coordinate of my vertex is 2. So I'm going to make a little table here. I'm going to organize my work. And in the middle here, I'm going to put a 2. And you'll see what I'm going to do on the other two sides. All right, now I'm going to put 2 into the original equation. So that's y equals, use parentheses, squared minus 4, use parentheses, plus 4. This is going to be 4. This is going to be -8 plus 4. And in this case, that's going to end up equaling 0. So my y-coordinate is 0. So my vertex occurs right here at 2, 0. Okay, now normally I would label it, but this graph is numbered really well. Now since there are no other zeros, there's my one solution. My one solution is the same thing as my vertex. I got to go looking for some other numbers. I'm going to put some x values in. Now, I like my work to be easy. I'm going to put 0 in for x. Watch what happens, pardon me. Watch what happens when I put 0 in for x. I get y equals 0 squared minus 4 times 0. And then what is it? Is it plus 4? Yes, it is plus 4. Okay, plus 4. Well, all of those terms, those x terms, turn to 0, don't they? And so I'm going to get y equals 0 minus 0 plus 4, or better yet, just 4. So when x is 0, y is 4, so right there. Now, the next part of this is super simple, because parabolas are symmetric, which means if I move 2 to the left from the vertex, and I go 4 up, you see I moved 2 to the left and then went up 4. That means if I move 2 to the right, in other words, make x 4, I have to move 4 up. I guarantee that the point 4, 4 is on this parabola. If you don't believe me, plug 4 in for x squared. I'll tell you what, I'll even do it just to prove it to you. I'm going to plug in 4 for x, and watch what happens. I'm going to get 16 minus 16 plus 4. 16 minus 16 is 0. 0 plus 4, 4. Just like I said. But I didn't really do any math to get it. I used symmetry. Parabolas are symmetric. If you put 1 in for x and get the answer out, then if you put 3 in for x, you'll get the same answer because of symmetry. So now, on paper, it's real easy. Please don't laugh at me. I'm going to draw my parabola something like that. And that's actually one of my better parabolas considering I'm using the airliner. It's very difficult for me. But I'm doing the best I can. On paper, it's a lot easier. There you go. So let's see what we did. We found the discriminant, just like always. When we found out there's only one solution, we didn't even use the whole quadratic formula. We went right for the vertex, because the vertex is the one solution. It is the x-intercept. Then I used a table to help me get the other points. So let's try another one. All right, here we go. Let's just get right down to it. A, B, C. Easy as 4, 4, 2. Okay, do the discriminant. B squared minus 4, A, C. So this is 16. And this is 16 times 2 is 32. So my discriminant is going to be a negative 16, which, if I were Alice and Pasquale, I would say there are no solutions. In other words, no x-intercepts. That does not mean you can't graph this. It just means it won't touch the x-axis. So to use the quadratic formula at this point would be foolish because you're going to get imaginary numbers. You're going to be taking square roots of negatives, which you cannot do. So we're going to go right to the vertex. It's vertex time. And x is going to equal the negative of b over 2a. Oops, got ahead of myself there. Sorry about that. That should be 2 times 4 in there. All right, that looks a little bit better. Okay, when I do that, I get negative 4 over 8, which would be negative 1/2. Okay, that is only the x-coordinate of the vertex. To find the y-coordinate of the vertex, I am going to use a table. But quickly, I'm just writing this down. Plus 2. Did I get all the signs right? If I don't have all the signs right, it's not going to work. Yeah, it is right. Okay, so now I'm going to use a table. I'm going to go x, y, and I'm going to put negative 1/2 in for x. Okay, so I'm going to come over here and go y equals 4 times negative 1/2 in parentheses plus 4 times in parentheses negative 1/2 plus 2. Okay, so this will equal 4 over 1 times 1/4, because a half times a half is a fourth. And then the negatives are canceling out. Here I have 4 over 1 times negative 1/2, and that's multiplication. And then I'll add 2 to whatever I get for an answer. So Wonder Woman shows up, and those cancel, and I get 1. This goes into here 2 times negative 1, negative 2, and then plus 2. And you know what? I like to work smart, not hard. I know that these two make 0. These two cancel each other out. I'm left with 1. So my vertex occurs at negative 1/2, right about there, positive 1. Okay, now I know this is going to have to open upward because there are no zeros. So it can't open downward and cross the x-axis in this particular problem. All right, I love to put 0 in for x. So if I put 0 in for x into my table, I'm going to get y equals 0 plus 0 plus 2. Hey, by the way, when would be the only time I couldn't put 0 in? That's right, if the parabola was passing through 0, like the vertex was at 0, at the origin. Right, I'd have to put a different number. If the vertex is on the y-axis, then I have to pick a different number. Now again, I'm going to work really smart. This is a half a unit away. So I'm going to go half a unit in the other direction, which would be negative 1. Now I don't have to do any math because of symmetry. If I go half a unit to the left, I'm going to go up 2. Yeah, because of symmetry. Watch, I go, whoops, stop moving. I go half a unit to the right, up to 2, up 1 unit. I think I said up 2 before. I mean up to 2, up 1 unit. Half to the right, up 1. Half to the left, up 1. My parabola is going to be like that. And let me see here. Zoop. And zoop. There we go. All right. That's it. That parabola is graphed. Let's try one more. And we'll see how quickly we can do this without losing you. All right. We got A, B, C. Easy as -9, 12, -6. Go looking for the discriminant. 12 squared, I think that's going to be gross, -4 times -9 times -6. Well, 12 squared is 144. I was right, it is gross. I've got 3 negatives there, so it's going to be minus 36. 4 times 9 is 36. Right? 36 times 6 is going to be 6, carry the 3, 216. I'm going to get a negative answer here. Yeah, I'm going to get a negative answer. Let's see, I'm going to get, it's going to equal negative 72, I believe. So there are no x-intercepts, no solutions. Okay, so I'm not going to go looking for them. I'm not going to use the quadratic formula. Now I'm going to go to my vertex. X is going to equal the negative of b over 2a, which I think would be -9, like that. So I'm going to get a positive 12/18, or better yet, 2/3. How did I get a positive? Because the numerator is negative and the denominator is negative. So 12/18 simplified to 2/3. All right, table time. That's only the x coordinate of the vertex. I need the y coordinate of the vertex. Why? Because I need it. Okay, so let me see here. We've got -9x squared plus 12x minus 6. So we got y equals -9x squared plus 12x minus 6. All right. So I'm going to plug 2/3 in. So we get -9 over 1 times 2/3 squared plus 12 over 1 times 2/3 minus 6. So do my little math here. I'm going to get -9 over 1 times 4/9 plus 12 over 1 times 2/3. And it's time for your favorite female superhero, Wonder Woman. She's going to show up, and I'm going to get -4. Here, Wonder Woman's going to show up, and I'm going to get 4. I'm going to get a +8 and a -6. And so I have 10 negatives, 8 positives. This must equal -2. So my vertex occurs at 2/3 -2. Notice this one's going to be below the x-axis. 2/3 -2, maybe right about there. All right, now I love to put 0 into my table. I'm going to go 2/3 to the left to get to 0. When I put 0 in, I believe I'm going to get a -6 out of it. Yeah, put -6 or 0 in for x. This turns to x. This turns to x. I'm left with a -6. Okay, now if I go 2/3 to the right, well, 1/3 would take me to 1/2. Another third would take me to 1 1/3, right? Or 4/3. And that has to be at -6 also because of symmetry. So 0, -6 is here. 1 1/3 -6 would be right about there. And then I can draw, or attempt to draw. I missed the point. Oh, the parabola. That first part doesn't look so good. Let me see if I can. Oh, maybe I can just cheat and kind of move him over there. Kind of push him up a little bit. Yeah, it's pretty close. I have a hard time with the parabolas on the airliner. Okay, there you go. So we found the discriminant just like before. Since we found 0 or 1 solution, we went to the vertex. We didn't use the quadratic formula. And then once we had the vertex, the x-coordinate of the vertex, we went for a table to get the y-coordinate of the vertex, to get one of our other points, and then we use symmetry to get the third point, and we're ready to draw our parabola. All right, ladies and gentlemen, that is the video for tonight. Mr. Lawrence signing off. Have a good night, everybody.